SwayamPrabha. Digital India. Educated India.
Hello, I welcome you all in this course on refrigeration and air conditioning. Today we will discuss the design conditions, because when an air conditioning system has to be designed, we have to fix the design conditions. Air conditioning is used for variety of applications, starting from human comfort, commercial applications. Air conditioning is used in the shopping malls, commercial areas, warehouses, preservation of foods, cold storage, laboratories. I mean, there are many applications of air conditioning system, but we cannot fix universal design condition for all the systems. But in the most of the systems, now ambient temperature for summer, especially in India, for designing the system, the summer time ambient temperature is considered to be 43.2 degrees centigrade. That is the standard value. Second thing is, load calculations we will be discussing in the subsequent lectures. But suppose we have load in a building. Suppose load in a building is coming 100 tons. Now, should we go for a 100-ton refrigeration system or a 100-ton air conditioning system? That is the point, because if we choose the air conditioning system with the peak load, because load on AC will vary. Load on AC will vary throughout the day, and the maximum load will be between 3 p.m. to 4 p.m. Right. So, normally it is like this. So, the peak load is 100 tons of refrigeration, but the issue is, if I go for a 100-ton machine, my machine will be underutilized throughout the day, except this period. If I take 50% of this load, like 50 tons of machine, in the 50 tons of machine, this is 100 tons. Suppose this is 100-ton load. If I take 50 tons, then my machine will be overstressed, and that will cause maintenance power. If the machine is overloaded, that will call for maintenance of the machine. So, that is why when we design an air conditioning system, first of all we calculate load in the building, maximum load in the building, and capacity of the machine is desired close to the 75% load of the building, because we have to see this flatness of this curve also, but in any case it is approximately 75% of the peak load in the building. For the air conditioning in the cold storage, it is interesting to know that for different food stuff there is a different preservation temperature. For example, we take potatoes. Potatoes have to be stored around 3 to 4 degrees centigrade temperature, but normally they are stored at 0 degrees centigrade. That is not advisable, because this preservation temperature is the optimum temperature where the ripening effect in the food stuff is minimum. Bananas 14 degrees centigrade. We do not have to keep bananas in refrigerator. Another example I will give you, mangoes. Mangoes also around 10 degrees centigrade. Milk. Milk is 0.5 degrees. So, this is very close to 0 degrees centigrade, approximately 0.5 degrees centigrade. So, if you look at the ASHRAE handbook of refrigeration, you will find preservation temperature of all food stuff, and all food stuff, for the sake of preservation, should not be kept into the refrigeration. So, for every food stuff there is a specific temperature for preservation, and it should be kept at that temperature only. So, now regarding the design condition in air conditioning system, I have already told you the outside design condition, temperature of air is normally considered for summer air conditioning 43.2 degrees centigrade. Inside design, inside design there are two things, temperature and humidity. Ideal case, we say that temperature has to be 24.4 degrees centigrade, but in India we continue with 25 degrees centigrade. If you look at the psychrometric chart, it is indicated as 24 degrees centigrade. We go for 25 degrees centigrade because in our country the air conditioning now till date the air conditioning means cooling of the air, and cooling from outside air is 43 degrees centigrade. If we are cooling up to 25 degrees centigrade, we are saving some amount of energy. In fact, even if the temperature of a room in the summer season is maintained at 27 degrees centigrade, it should work provided there is a proper movement of air in the room. So, humidity is also important. Humidity here it is 50%. Here also we assume that humidity should be 50%, but this is the issue with the humidity also. It is not always possible to maintain 50% humidity, so it is maintained in a particular range. Now, I was talking about this 27 degrees centigrade. Even if we maintain 27 degrees centigrade temperature with proper movement of air, you will feel quite comfortable. Air movement is also important in the occupancy. The air movement normally it is 0.1 to 0.3 meters per second. If you exceed 0.3 meter per second, then the movement of air shall also become uncomfortable for you. So, it has to be lower than 0.3 meter per second, and but has to be more than 0.1 meter per second. Otherwise, if the proper air movement is not there in the room or in the building, certain pockets will be created in the room, and high temperature differential will be formed in the room. In a room, for the purpose of air conditioning, the temperature difference between 2 points in the room should be less than 1 degree centigrade. If it is a house, in the entire house, the temperature difference should be less than 2 degrees centigrade in any part of the house. Now, air movement. Ideal air movement is 0.15 meter per second. It turns out to be approximately 9 meters per minute. Yes, it is 9 meters per minute, right? So, if proper air movement is maintained in the room, we can go up to 27 degrees centigrade. There is a concept of draft. There is the equation for draft temperature difference, that is delta T, that is equal to T minus 24.4 minus 0.1276 V minus 9.1. Now, this equation, if velocity is doubled, I mean 9 meter per minute, if I double the velocity, I make it 0.3 meters per second, then for same draft feeling, then 9 into 0.1276. This T can be 24.4 plus 1.15. So, we can go temperature by higher by 1.15 degrees centigrade. If this T is 25 degrees centigrade, so 26.15 degrees centigrade or 26.5 degrees centigrade we can go up to if we increase the velocity from 0.15 to 0.15 to 0.3 meters per second. This is the upper limit. So, comfortably because this temperature is 25, even if the temperature is 26 degrees centigrade in the room, you will not feel uncomfortable. So, we can easily go up to 27. Why I am stressing on 27 degrees centigrade? I am stressing on 27 degrees centigrade because if you maintain 27 degrees centigrade temperature in a room, outside temperature is let us say 40 degrees centigrade, and you are reducing temperature in a room to 27 degrees centigrade, that is 13 degrees centigrade reduction in the temperature. In another case 40 degrees centigrade. Nowadays I have seen the people, normally maintaining the temperature of the room 22 degrees centigrade, and then it becomes 18 degrees centigrade. So now 13 to 18, there is a difference of 5 degrees centigrade, and I mean 30%, approximately 30% more energy is consumed in maintaining this temperature. And it is not advisably, thermodynamically it is not advisable to sit in a boardroom of a company in a 22 degrees centigrade wearing a warm suit or wearing a suit. So clothing is important, especially in Japan. What people are doing, even in the corporate meeting, they are going with the light clothing. Clothing makes a lot of difference. That we will cover in subsequent lectures, how the clothing of an individual affects the temperature in the room. I mean, if you go for the light clothing, the higher temperature in the room will give the same order of comfort. Now we have already discussed the draft. Now in summer air conditioning, the outside temperature, suppose air conditioning is done in the desert area. Outside temperature is 40 degrees, 45 degrees centigrade, humidity is 10%. You need not go up to 50% of relative humidity. Even 30 to 40% relative humidity will serve the purpose. On the same side, if there is a coastal climate, the temperature is 35 degrees centigrade, humidity is 60% or 65%. That is quite uncomfortable. Those who live in the coastal area, they can feel this is more uncomfortable than this. In dry weather, suppose you are standing under a shade, it is a big relief. But if the humidity is high, though the temperature is low by 10 degrees centigrade, this weather makes you very, very uncomfortable. Anyway, so 35, 65, we can reduce the humidity to 60 or 55%, it will do. We need not go up to 50%. Same is case with the temperature. Suppose outside temperature is 45, I think 27 is okay. But if the outside temperature is 5 degrees centigrade in cold, in the winter, outside temperature is 5 degrees centigrade. In that case, I think inside temperature you can maintain 23 degrees centigrade. So these are the measures to save energy, because a good design of a system is, especially in air conditioning system, which saves energy, because there is a lot of stress on energy saving in the air conditioning system. Now second thing is, if you go for the small capacity type of system like split air conditioner, split air conditioners are good. I mean, aesthetically also they are good, but they don't have any provision for fresh air. So this has to be kept into the mind. I have seen in the buildings, instead of putting a 20-ton units, they have put a split ACs. That is not advisable, because split AC is not made for such type of applications. And it is not an energy efficient system also. If you are putting 10 split AC of 20-ton capacity for a 20-ton requirement, you are putting 10 ACs of 2 tons each. This arrangement is, first of all, is not very energy efficient system. Second thing is, in this type of system, there is no provision for fresh air supply. These ACs are manufactured, are proposed for small capacity cooling. In a small capacity cooling means residential cooling. In residential cooling, through infiltration only, through infiltration itself, you get a lot of outside air inside the building. Right? This is not possible sometimes in the commercial buildings, and then again in the building, sick building syndrome appears. I have already explained you what is sick building syndrome. Sick building syndrome is the syndrome when you enter the building, you feel sick, and you feel sick because the quality of air in the building is not maintained. Effective temperature. Effective temperature of, let us say, 21.7 degrees centigrade. What is effective? Effective temperature is the temperature of saturated vapor. Temperature of saturated vapor at which you get the same comfort feeling as you get in the case of 24.4 degrees centigrade and 50% RH, and that temperature is 21.7 degrees centigrade. And if you follow the effective temperature line, it is like this. If temperature is high, effective constant comfort line, this is this one. If the dry bulb temperature is high, you can go for lower relative humidity. If the dry bulb temperature is low, even if the humidity is high, it will give you state of comfort. I am not able to draw with the proper inclination, it is like this. So, if for the high dry bulb temperature, you can go for lower relative humidity. For low dry bulb temperature, one can go for high humidity. And for designing an air conditioning system, depending upon the outside condition, we can take the range of relative humidity as 30 to 70% and temperature in a range of 23 to 27%. But this condition, this should lie on this curve, effective temperature curve. Clean space. Now for designing a system, we do not have to maintain the temperature and humidity. At the same time, we have to maintain the cleanliness of the air also. It should be free from the pollutants. So filters are provided. And cleanliness, I cannot simply say that this air is clean and this air is not clean. It cannot be said in a simple and straightforward manner. So the cleanliness of the space is classified. It is classified, I will say it is a class 1000, the class 1000 air, class 100 air, class 10,000 air, class 1 lakh air, like this. Now what does this class mean? For example, suppose there are 50 particles per cubic feet of size greater than 0.5 micron, size of the particle is greater than 0.5 micron, and number of particles is 50 per meter cube, it is class 100. If it is 850, then it is class 1000. If it is 7850, then it is class 10,000. Now for the surgery room, for the medical applications, for the surgery room, class 1000 is recommended. There is class 1 also. Your mobile chips are manufactured in class 1. No particle has dimensions greater than 0.5 microns. So it is free from any particle of this size, and human occupancy is not allowed. The moment you enter this room, the class will change. Even for class 100, special type of suits are there. One has to wear those suits before entering the class 100 environment. Otherwise, the class of the environment will change. So in order to this maintain, so in addition to the temperature, humidity, the air movement and the cleanliness of air has to be maintained inside the building. Now for medical applications, special type of design conditions are there for medical applications. For example, there is a ward for burn patient. Ward for burn patient should have 32 degree centigrade temperature. So burn patient should be kept on high temperature and humidity should be very high, 90%. You may not like to stay in this environment, but burn patient should be kept in this environment. So for medical applications, for hospital air conditioning, very special type of arrangements have to be made. For example, there is a room where a patient is suffering from some contagious disease or immunosuppressant. Suppose a patient is suffering from AIDS. He should not get infection, or outside air should not enter this room. What should we do? Or another example, on another extreme, suppose in a desert there is a communication box, it has a lot of electronics equipment, and this box has to be dust free. So how to maintain this box dust free in dust environment? How to maintain this room free from outside air? The simple solution is these chambers have to be positively pressurized. we can positively pressurize a chamber up to 15 Pascal by providing the excess air. It is a centralized AC system, excess air is supplied in the room and it is positively pressurized, so that outside air does not enter the room and patient gets infected. Another room, another patient is suffering from some contagious disease. So the people surrounding this room should not get any infection from this patient. In this case, negative pressure is maintained in this room. And negative pressure is maintained in this room, so the outside air can enter this room, but inside air will not leave this room. So this is how the air conditioning is done, because hospital air conditioning is very critical. Somebody should not, or any patient should not get infection from some other patient. So the isolation rooms and OPDs, a special type of air conditioning is provided in hospitals. Anyway, we have already completed the clean spaces. Now the buildings, there is a LEED design of the building. Yes, LEED, you must have heard of this. Leadership in Energy and Environment Design, LEED. And you must have heard that in Hyderabad or in Gurgaon or many other places, or in Bangalore, they are LEED certified, platinum building, gold building, silver building. So these buildings are LEED compliant buildings, and LEED is a point system. And for different activities, there are certain points. And for example, there is a sustainable site. For that, there are 14 points. Water efficiency, you are not using potable water for gardening purpose, and there are many points on this. That is water efficiency, how efficiently the water is being used. Energy and atmosphere, material and resources, there are 13 points of material and resources. Indoor environment quality, the 15 points are kept for this. The next to the energy is indoor environment quality. And innovation and design process, how you are using the local material, how innovative you are in your design. So all these points together, they form 69 points, and if any building earns between 50 to 69 points, it is called a platinum building. Now sustainable sites, there are certain sub points also, I will read them one by one quickly. Erosion and sedimentation control, site selection, development, density and community connectivity. Connectivity is also important because we are talking about the sustainable sites. Brownfield development, reduced size disturbance, stormwater management, reduce heat island, light pollution. Light is also a pollution. In urban pollution, light pollution is also noticed if the places are over illuminated. That is not desired, because in earlier days, and over illuminated places, they consume more energy also. In earlier days, in a room, in a normal reading room, the illumination was recommended around 900 to 1000 lux. Nowadays, it is reduced to 300 to 400, because most of the time we are working on the computer and fine printouts are available. So 300 to 400 lux of light is sufficient for the office occupancy. So this is how the energy can be saved. And water efficiency, water efficient landscaping, water use reduction is also, it carries 2 points. Then energy and atmosphere. If you are using some ozone safe fluids or ozone safe technology, that also earns 1 point. And green power is also given 1 point. So there are many points in this, and these accumulated points turns the building into this classification. This is certified silver, gold and platinum, right? And after the LEED, there are certain general design guidelines. There are thumb rules. I mean, so the system cannot be designed using thumb rules. Thumb rules are just for cross verification. We should do our analytical calculations and compare our results with these thumb rules, and values are, if values are very close to each other, then we say we develop a confidence in our design. For example, per ton of cooling 400 CFMs should be there. But if you look at the split AC or window AC, if you look even a 1 ton or 1.5 ton AC, this requirement is not met, but it does not mean their design is faulty. So, it is a rough estimate that in a centralized, especially this is for centralized air conditioning system, the 400 CFM per ton of cooling for normal comfort application, 500 CFM for heating purpose, 300 CFM where latent heat is high. For example, kitchens, restaurants, dance floors, gymnasium, where I'll explain later on how they contribute more latent heat because there are more vapors in the kitchen or in the restaurant. So, latent heat addition is high, so 350 CFM, 1 CFM per square foot of floor area. So, if it is a room of 10 feet by 10 feet, so approximately 100 CFM should be circulation in the room. Normally, if 10 feet by 10 feet we are using 1 ton of AC, then not 400 CFM, it is a window AC, then it is going to be 200 CFM, 150 to 200 CFM, but in any case it is more than 1 CFM per square foot of floor area. So, they are thumb rules. So, we do not have to design this, please bear in mind, with the thumb rules we do not have to design the system, but the values which are getting after designs, they can be cross verified. For example, 7.5 air changes per hour in a building should be done, but normally in a building, in a commercial building, 6 to 8 air changes are normally ensured. Building pressure 10 to 15 Pascal, that is for pressurized building. Thermostatic expansion, superheat should be in a range of 4.5 to 6. This is for expansion wall. Subcooling before entering the expansion device 3 to 8 degrees centigrade, normal air temperature drop 10 to 12 degrees centigrade, normal condenser air temperature rise because the air takes away the temperature from the condenser 17 degrees centigrade, chilled water temperature rise or fall in a range of 4.5 to 5.5 degrees centigrade. They are simply rule of thumbs, but the values should hover around these values. So, this is all for indoor and outdoor design conditions. More on indoor design conditions we will be discussing on the subsequent lectures. This is all for today. Now, in the next lecture we will take up the cooling load calculation.